Problem 14, longest common prefix. So in this problem, we have an array of strings, and we basically have to find the longest common prefix. Yeah. So this will be, May will be the longest common prefix here without space. So we basically have to return May, yeah, as a string. Now, in order to do that, I will propose the following algorithm. Let's come up with a variable k, which we'll set to 0, and the intuitive kind of meaning for this variable will be, this will be the length of common prefix. So I'll think about this as how many characters have I checked so far? And I know that all of these strings in the array, all of them, have that many characters as a common prefix. So initially, obviously, I can say that, well, I've checked 0 characters. Excuse me. So I've checked 0 characters, and I am sure that all of these strings have 0 characters in common. And now I have to check next character. And the index of the next character will always be the same, k, right? Because if I've checked k elements, then the next character will also have index k. This is because of 0-based indexing, right? If we were using 1-based indexing, then I would be checking k plus 1 character with that index. But because of 0-based indexing, I will always be checking character with index 0. So in the first case, initially, we'll be checking the 0th character with the index 0 in every string, okay? In every string. And ensuring that they are the same. So first of all, they should exist in every string. So the length of every string should be at least k. And then all of these elements should be the same. And to check that they're the same, I'll just compare all of them to the very first string. And the first string is obviously what? The one with index 0. So that's our array. And element with index 0 is going to be a string, right? So this is a string. And then kth character here will be this, right? So I'll make sure that let's say this is one of those strings, right? And at some point, it's fine if it points to our model string. If it points here, I'll still be checking whether kth element here is the same as this, okay? So this should be the same. So while this equality holds, I will keep incrementing k. And in the end, I'm going to return I'll take again our initial string, this guy, and we'll take first k elements and return it, okay? So let's try to implement this now. As we said, we're going to first declare k and set it to 0. Now we're going to do some while loop. I'll write the condition in a minute. Keep incrementing k, and once this is done, we're going to return, let's say, strings 0, and then slice. Let's take first k elements. That should work, but normally what I would do is protect myself from the situation when this does not exist, when 0th element does not exist. That will prevent, instead of throwing an error, this will return an undefined, and I can just replace it undefined with an empty string or something else. In reality, probably throwing an error could be a good solution, actually a better solution, or actually returning an undefined could be even better. But this will never happen in our problem because we are assured that the string has at least one element. So basically here I'm just showing you that developers should not ignore these edge cases, even though here we are allowed to ignore these cases, right? We promise that there will be no weird edge cases, but developers should always be conscious of how their program will perform in case there's a weird input, right? So while, what's going to happen inside the while? Inside the while, we're going to say that every element in this array, every string in the array must have the same kth element. So this is how I'm going to do it. So the name of our array of strings is this, strs every. So every s, every string, every this. First of all, we said it has to have the length at least k, correct? Otherwise, that means we run out of elements, no more elements. So that's it for our aspiration to find the next common character in the prefix. Now, if s has sufficient length, then we can check the next element. So we can now touch kth element and make sure that it is the same as the kth element in our model string, which is this one, right? So this is our model string. That's a string, and we're going to take its kth element. Okay, so we're going to compare every string s to the very first string, or the string with index 0. Okay, that's what's going on here. And that should be it. I think we can run it against our initial pretests and hope, yeah, we passed these pretests. Let's submit to the full suite of tests and see how that performs. Yeah, and we did, I mean, it's not spectacular, obviously. We're using this every, but I think this is a decent solution for JavaScript. This is, so we've beat about half of the solutions and slightly more, about 70% of solutions in memory. So speed, just half of the solutions, and in terms of memory efficiency, about 70%. Okay, that's fine for JavaScript.